Hello everyone. In this video, I will explain the fourth script which I have shared with you. The name of the script is GEE underscore exercise 4, and this is a preparatory script for your assignment as well. And in this script, what we're doing is the script does random forest based crop type classification based on Sentinel-2 and Sentinel-1 data. So as usual, we are starting with importing some data sets. The first one is Meandop scheme boundary because we need a crop type boundary, crop type map inside Meandop scheme. I'm also importing some field data, which is a ground truth collected in 2019 as explained in the lecture. And that is imported as a variable called field. And this will be used for training and validating the crop type map, and also importing two image collection. One is Sentinel-1, which I named S1. Another one is Sentinel-2, which I named S2, and you can see the details here. And the MIS and field are shared to you so that you can also access. So when you print field, you can see all the details about the field data, the table, the columns which are available, the classes, etc., etc. So you can check what is coming in console here. Um, the next step is to center the object, center the map to MIS. Please see my previous video to understand what center object is. And following that, we are adding a function to place a legend here in the map view. And this function, like any other functions, you can copy and reuse it any other script for you adapting to your purpose. And here the major part is where we define the class palette. Here you can see I'm giving hexa code for each color to each classes. These are the classes we are going to classify, and for all these classes we have data available in the field points, field vector data. And you can also see the name of the legend I'm defining here. You can change this name in case if you want to reuse it in any other study area once you have field data. And this hexa code is coming from this is a standard form of representing colors. You can always go into your browser and say hex code colors, and there are many websites which will give you option to get hex code for colors. For example, the first one itself, you can check HTML color codes, and you can select any colors here, and this is the hex code. So you can, for example, if you want to use this color, you can copy this and bring it here and use it. Sorry. Uh, okay, you can copy this, bring it here, see like this, and use it without the hash. And this is the same we are using here. So this is how you can get hex color code for if you want to define other colors. So here, so this is where the legend function finish. You don't have to go in detail here because yeah, I mean it works as such, and you can adapt it. And other functions are defined here. One of the function is function mask S2 clouds, which will mask out Sentinel-2 clouds here. This is a standard function available in the documentation, which I have put it here. And the next function is mask L8SR, which will mask out clouds from Landsat 8, actually surface reference data. For TOA, there will be some changes here, but you can check the documentation. I think those functions are also there online. So the functions end here. Now here we are going to define the required Sentinel-2 images. So what I'm telling here is select the required images from Sentinel-2 image collection imported above. We are defining four variables: season 1, 2, 3, and 4. Select required Sentinel-2 data from the respective season. and apply cloud mask and apply median filter and clip to MIS boundary. So that is what we do in one patch. So here, season one. Season one starts from October to December 2018. We are taking all the Sentinel-2 data which has a cloud with pixel percentage less than 25% because it's winter. I gave a higher threshold. Um, then filtering to MIS because we need only those Sentinel-2 images which cover MIS. And then dot map mask S2 clouds. We are applying this function here by using the map function. Then find out the median from all the images available in between this timeline and clip to MIS and print the result. So similarly, season 2, season 3, season 4. So input data from Sentinel-2 is defined here. Now the next session is defining the false color visualization. By now you must be familiar with this code. So we are saying the false color composite for Sentinel-2 is B8, B4 and B3. Now here visualizing, we are visualizing season 1, 2, 3, 4 um, false color composite images from Sentinel-2. This false and true here means that whether it should be already enabled in the layer manager or not. So by false it means it will be switched off here in layer manager. By true it means it will be switched on. You can change it. Now here similar to S2 we are defining Sentinel-1 for each season. You can see the timeline here, median, then clip, then I'm selecting only the VH here and renaming it as VH underscore S1. The variable is also named as VH underscore S1. So I'm taking the vertical and horizontal part of the Sentinel-1 for season 1, season 2, season 3, season 4, median and clipped. Now we are creating a new image collection which is named Dataset. I'm giving that name. And you can see that all the season 1, Sentinel-2 and Sentinel-1 are all combined. Add bands means it will add bands of image 2 to image 1, image 3 to image 1 and image 2 like that. So it's adding all the bands together and making one single large data set. Now let us work on the field data. So here you can see that we are splitting the training data into training and validation. 70% of the data is considered as training, 30% as validation, randomly selected. So that is why we are providing a random seed of 1 here. And then it will divide the training data table to less than 70 percentage randomly selected as training and greater than 70 percentage whatever is left to validation. So that's how we split the field into training and validation here. Now a new feature collection with all the bands and datasets sampled to training points. All the bands and datasets are sampled at the training points here with this set of code. So you can see the collection is training here. The properties is class ID, which is a column which represent the ID of each class type. Please check the print field output in console. This one, the first one, to see what is class ID. It's one of the column actually. Then back to where we were. Now create a new feature collection with all the bands and datasets sampled to validation point. The same step repeat, but for validation points here. So that is this set of dataset. Sorry, script. Now we don't want to use the entire bands, all the bands available in Sentinel-2 for classification. We only want to use B2 to B12, season 1, B2 to B2 to B12, season 2. Now here I'm defining B2 to B. Okay, it's a bit difficult to select. B2 to. Let me use my keyboard. B2 to B12 from season 3, and B2 to B12 from season 4, and then each season Sentinel 1 band from season 1, season 2, season 3, season 4. So see that these are the bands which you want to use or we want to use for classification. It can change, so you have to make um, corresponding changes to these lines. If you want, for example, if you want to use Landsat 8, it will be B2 to B7 or 8. Please check my lecture slides. Now here we are printing some basic stats of training and validation points. Now we are coming to classification. Here we are creating a classifier using random forest, and here you can see I have set some parameters here and asking the Google Earth Engine to train using the features in training. Class properties, class ID, but only use the properties which are only use the bands which are given in the bands variable. So only these bands. So the data set is given, um, but we will use only. Sorry, the training is the sampled bands in the training is given, but it will select only those bands which are given in this list. Okay. Now, what are these? These are the parameters. How do you know these parameters? So you always have to refer to the uh, documentation. Select this one. This is the function. Go to docs, uh, search it, and you can see all the arguments. And these are the arguments which I have given here. So, for example, the first one is number of trees. So you can see that the number of trees in the decision tree. Please refer to the videos which I have shared. I can see I used 100 trees. You can play with it. You can change it to 150, 200, 250, and see if it is making any difference to the accuracy. So this is how you set with the parameterization. And 999 is a random seed. It always need a randomization seed where it can start. If you change that value, also the results will change a bit, not a lot, but sometimes it affects the accuracy as well. So it's a bit of trial and error method where you run with the different parameters and find that after some time, when you change these trees, number of trees or other parameters, the accuracy won't change much. So that is when you know that okay, this could be a good set of parameters for this particular area of interest. So this is where this is where you can change this line to any other method. So how will you find other methods available? So if you search for ee.classify here, you can see a list of classifiers available here. You can see SVM, minimum distance, decision tree, um, cart. You just mile cart. Please use mile cart because the simple cart is deprecated now. So you can check this documentation, for example, and see what it needs and replace this line with that, and the Google Earth Engine will use that particular method. Now, once the classifier is defined, you will apply this classifier to data set, which is the combined image collection we created. Now I'm applying a focal filter using the median with one radius. Please search for this function in documentation and clip the result to MIS. And this median filter is to remove salt and pepper effect. So this line will give you the classified image. Now here the rest of the image code, we are calculating the confusion metrics. In other words, it's called error metrics using class ID and classified image and reporting different statistics, the overall accuracy, consumer accuracy, kappa, etc. And now in here we are adding the classified image with the palette which we have defined in the beginning and adding the legend. So you can save it and run the script. You should be able to see the map here. So here you can see in the console all the objects which are asked to print. It will consider I got the overall accuracy of 84.4 here. Why is it showing here? Because we are printing the overall accuracy here. So it's a result of this line. Like that, you have all the results, whichever. And let's see the first one, the feature collection, which I've shared with you. So you can see the feature collection, the ground to 2009, which are the columns available. So this is the class ID. So that is why we were giving class ID here. So that means please use that column to get the class ID, like the crop type ID or land cover type ID. So for example, build up is one. Um, yeah, you can also if you want to visualize these points here, yeah, so you can also add those points here, right? So at the end you can also add field. Sorry, there's a wrong command. Map dot add layer field. I don't want any visualization parameter here. I'll give something called ground truth, which is a text here. And if you run it again, you can see that that will also show here. Come here. And so you can see the points. I will come here. If you want to see the details of one point, you can also put satellite, and you can click on one point and it will show you here. So it's showing the details of um, the inside the pixels. No, it shows all the Sentinel-2 data, the classified image, because you have the classified image. So according to classification, it's class 9. There, then in the objects, in the ground truth, you can see the properties. Crop type is stone fruits. Class ID is 9, which is others. So I put stone fruits into the class 9. So in that way, you can visualize these points and see the details. And that details will show inside objects. Hope this will help you to navigate through the classification exercise and make you understand more about what is scripted here. Thank you.